All right, not entirely sure why my video went out there for a minute, but it is back now. So, moving forward with objective 3, we want to solve equations of fractions or decimals as coefficients. So to avoid messy computations of fractions, we can clear equations of fractions by multiplying each side of the equation by the least common denominator, the LCD, of all fractions in the equation. This gives us an equation with only integer coefficients. So this is going to be with fractions, but if you ever had a problem with decimals, you would just want to multiply by either, if you had a decimal that was 0.1, you multiply each value by 10 just to get rid of that decimal place. So any kind of deviations of 10, so 10, 100, 1,000, however many you need to get rid of those decimals. So with fractions, though, we want to find the least common denominator of all the fractions in the equation and then multiply out by each term so that we can go ahead and get whole numbers. So this gives us an equation with integer coefficients. Integer just meaning our whole natural numbers, so 1, 2, 3, 4, 5, so on, 0, and the negatives. So example 2, we want to solve this equation. If we want to solve this equation, we have to find the least common denominator, or the LCD. We have to find the LCD. So we see our denominators in this case are going to be 3, 4, and 6. So we want to find what number that can have factors of 3, 4, and 6. We could go ahead and multiply 3, 4, and 6 together, but there's probably going to be a smaller number, and there is. So the number, when we multiply 3 by 4, we end up with the value of 12. And 6 is a factor of 12. So our least common denominator in this case is going to be 12. It looks kind of funky. So our least common denominator is 12. So we're going to take 12 and we're going to multiply 12 by each term in our equation. So, and this falls under step 1 because we're getting rid of our fractions. We're clearing our fractions. So we're taking 12 and we're going to multiply it by 2/3 x. We're multiplying it by 1/4 x. We're multiplying it by -5/6 x. And we're also going to multiply it by 3. So we took our least common denominator and we're multiplying each term. So when we multiply these values together, this now gives us 12 times 2 over 3 times x minus 12 times 1 over 4 x equal to 12 times -5 over 6 x and 12 times 3. 12 times 3 is going to give us 36. So now let's go ahead and start simplifying. If our denominator is 3, we can factor 12 into 3 times 4 times 2, all divided by 3. So now we see we have a 3 in our numerator and our denominator, and we get our property of 1. Then 12 times 1 is just 12, and we know that we can factor 12 into 3 times 4. This is also times 1. Now with our denominator of 4, once again, we have our property of 1 here. We have a 4 in our numerator and a 4 in our denominator. Then with 6 as our denominator, we can extend 12 into 2 times 6 times -5 still, divided by 6. And once again, we have 6 in our numerator and our denominator, creating that property of 1. And we still have a -36. So simplifying here, with our 3 over 3, we have 1 times 4 times 2 over 1x. Then 4 over 4, we have property of 1 times whatever was left over, so 3 times 1 over 1x. Then in our numerator, we have, or on the other side of our equality symbol, 6 over 6 is just 1, and we have 2 times negative 5 over 1, still minus 36. So all of our 1s are now going to go away since we know 1 times anything, it's just whatever we had left over. And since we have each one of these terms with 1 in our denominator, we know that these are going to be whole numbers, or they're going to be integers. So 4 times 2 in this case is going to be 8. 3 times 1 is 3, divided by 1 is 3. So we have 8x minus 3x is equal to, and I realized somewhere along the way I dropped this x. Sorry about that. Then we have 2 times negative 5x is going to give us negative 10x minus 36. And now I want to combine terms. So 8x minus 3x is going to give us 5x. And negative 10x minus 36 is in its simplest form. So now we've completed step 1. On each side of the equality symbol, we simplified our expressions. Moving on to step 2, we want to isolate our variable to one side. We see that negative 10x is less than 5x, so we're just going to add 10x to both sides. So we get 5x plus 10x is equal to negative 10x minus 36 plus 10x. Ooh, we are totally going to run out of room here in a second. 5x plus 10x is going to give us 15x. Negative 10x plus 10x is going to give us 0 minus 36. So we end up with 15x is equal to negative 36. So let's go ahead and kind of move our next information down here, because we're going to run out of room. So momentarily. All right, so we made some more room for ourselves here, and we can move on to step 3. Since now we've isolated our variables and our constants to each their own sides. And now in step 3, we want to make our variable have a coefficient of 1. So in order to do that, we'll need to divide each side by 15. And now this will give us 1 times x is equal to negative 36 divided by 15. And now we want to simplify. So we have negative 36 times 15. Since 36 was negative and 15 was not, we know our answer itself is negative, so we can just write our negative on the outside. Then 36 and 15, they both have a common factor, and their common factor is going to be 3. So let's go ahead, kind of extend out our numerator and our denominator by factors of 3 and whatever other number it was. So 36 can be extended into 3 times 12, and 15 can be extended into 3 times 5. We see we have 3 in the numerator and the denominator, and using our property of 1, this gives us x is equal to 1 times negative 12 over 5, which is just x equals to negative 12 over 5. So that's what we got as our value of x here. And now we want to check our answer. So we want to plug this value into our original equation and see if it ends up making sense. So let's bring up our step 4 here so we can view our original equation. So we want to plug negative 12 over 5 in for x. So we have 2/3 times negative 12 over 5 minus 1/4 times negative 12 over 5. Oh yeah, no more x's. Negative 5 over 6 times negative 12 over 5 minus 3. All right, so let's zoom in a little bit more here. So we want to multiply these values together. So in our first term here, we're going to get negative. Since we have a negative times a positive, we're going to end up with a negative fraction in all. So we have 2 times 12 divided by 3 times 5 minus, and this is going to be negative because we have another negative fraction multiplied by a positive fraction, and this is going to give us negative 1 times 12 over 4 times 5 is equal to, and now we have a negative times a negative, so our answer will be positive. We have 5 times 12 divided by 6 times 5 minus 3. So there's going to be quite a bit of expanding and kind of canceling terms out in this next step. So negative 2 times 12, we know 12 can be expanded into 3 times 4. And in our denominator, we have 3 times 5. Then in our next value here, 12, once again, can be separated out into 3 times 4. And in our denominator, we have 4 times 5. In our next value, we have 5 times 12, which can be separated into 2 times 6, with a 6 still in our denominator, and minus 3. So let's go ahead and identify what values we still have in our numerator and our denominator. So we still have 3 in our first term in our numerator and our denominator. We have 4 in our numerator and our denominator in our second term. And in our third term here, we have 5 in our numerator and our denominator, and we also have 6. So simplifying this is going to give us 1 times negative 2 times 4 divided by 5 minus 1 times, and let's give these some brackets, 1 times negative 3 over 5. And the only value that we have on our left-hand side is 2. So we have 2 minus 3 on our left-hand side. The left-hand side is so nice. And now we can simplify. So we're going to end up with a negative 8 over 5. And now we have a minus negative 3/5, which is like saying plus 3/5 is equal to 2 minus 3, which is negative 1. Now we can just add up our fractions. Negative 8 plus 3 can be in our numerator since our denominator is 5. Negative 8 plus 3 is going to be negative 5 over 5, which is equal to negative 1. This is also like saying negative 1 times 5 over 5, which is just equal to 1. So this gives us negative 1 times 1, which is just negative 1. And we see that negative 12 over 5 is our solution. Or it's our final answer. So let's write in final answer here. So this answer did end up being, or this question did become quite a bit long, and that is kind of the thing you want to look out for when you have equations with fractions, because you can go ahead and multiply out by your least common denominator, and you can have an equation with just integers, But the issue then is that you have to factor it back into your original equation. So you may end up having to multiply out fractions again, and having a lot of kind of computation that you'll have to do. So it's important to look out for that. Thought it was important to at least go over one more difficult problem. So if you encounter them in your homeworks or exams, you'll have a little bit better understanding. So, all right. Some final words of caution here. When clearing an equation of fractions, be sure to multiply every term on each side of the equation by the least common denominator. So that's what we did before with our least common denominator of 12. Then, just as a note, in example 10, which example 10 was in your book, this is just to say that decimals are expressed as tenths and hundredths. So either 0.1 or 1.8, which are the tenths, so there's one number after the decimal place, or hundredths, where there's two numbers after the decimal place. So we chose the least exponent on 10 to eliminate decimal points, which made all coefficients integers. So we multiplied by 10 squared, which is 100. So this is in reference to their example 10, but the concept is still here by saying that when we multiply by 100, it's the same as moving the decimal places 2 places to the right. So that kind of turns our equation that looks like 0.1t plus 1 minus 0.05t is equal to 1.8. That turns that equation, once we multiply each term by 100, turns that equation into 10t plus 100 minus 5t is equal to 180. So that's what you'll need to do in the future if you end up having to multiply out an equation with decimals. All right, then our last objective here, we want to write expressions for two unrelated unknown quantities. So a problem-solving hint: when we solve applied problems, we must often write expressions to relate unknown quantities. We then use these expressions to write the equation needed to solve the application, and the next example provides preparation for doing this. So in example 3, we want to perform this translation. So we have that two numbers have a sum of 17. If one of the numbers is represented by x, we want to find an expression for the other number. So whenever we have problems like this, let's just give x a value. So we're just going to let the unknown number be equal to, let's say 10. A nice even number. And this is just for now. So just for kind of figuring out this equation, we're just going to say we're going to let this be equal to 10 for now. It kind of gives us an idea of what we're going to be doing. So we let the unknown number be equal to 10, and now we need to find this other number because we have two unknown values in this problem. We know that their sum is 17. One of them is going to be x, but we need to find the other number. And by this point, we're letting x be 10. So to find the other number, we can subtract 10 from the sum, which was 17. So whatever number we chose to kind of represent our unknown, we can subtract that from our given sum, which then this gives us 7. The actual value isn't incredibly important, but if you would like to know it, you can by all means calculate it. So we found this number, and so we want to use x instead. If we were to just stick with the value of 10, we know that this equation is going to end up giving us, because we have the sum, this would end up being 10 plus 17 minus 10, because we know that value is 7 is equal to 17, or 10 plus 7 is equal to 17. But we want to use x. So all we're going to do is we're going to replace x for 10. So we're kind of going backwards in the way that we've normally done it. So we want to use x instead. So our final answer is obtained the same way we got our last answer using 10. So in this case now we're replacing 10 with x. So our final answer is going to be x plus 17 minus x. And this will be our final answer. So when solving problems like these, it is easier to just assign a value what you're going to end up writing out instead there. So that now finishes up our that finishes up our section on 2.3. So see you again for section 2.4.